Hello. I am Jill Wang, and I will be doing the code review for the P1 project. So the P1 project is about the N-body simulation, which is the simulation that simulates forces between sort of planets, uh, stars, celestial bodies, if you will, and we'll create a simulation to simulate these forces. And so it'll seem like stars are rotating around each other or uh, planets are rotating around stars. And so that's pretty cool. And okay, so I'll be discussing a bunch of stuff about celestial bodies and N-body today. So here are my private instance variables. They are private to preserve encapsulation so that outside files or programmers that aren't supposed to know these values that are privy to specific instances of celestial bodies, uh, yeah, they won't be able to know what they are, and so we can protect our private instance variable information. So I'll be discussing this calc force exerted by uh, method and also calc net force exerted by X briefly. And so this takes in a parameter celestial body B, so an object of celestial body, and it basically does the GMM over R squared calculation to determine the force that B has on um, our this object, if you will, in Java. So 6.67 times math.pow 10 comma negative 11. That's just 6.67 times 10 to negative 11. This is how I chose to do the exponent. I thought it was cleaner. So that's the constant g times m, this mass of this object's instance mass, times b's, so the celestial b body's mass, divided by, and then we use this helper method, calc distance, to calculate r, the radius between b and this celestial body, and then we square that with math.pow. And so this is gmm divided by r squared. Let me turn that. And the way I handled edge cases such as self force calculations was that, for example, in here, I make sure that for B from bodies, which it contains all our celestial bodies, if that celestial body B is not the same object as like this instance of celestial bodies, then we'll do the calculations. But if it is, if the memory location is the same, then it is the same object. So then there'll be there'll be no force calculations, and so we avoid infinite force calculations that way. Okay, so now I'll be um doing N-body. So reading input file is read radius. So the radius is the second double of the files. For example, in here, it's the second double right here. So I skip over the first int and then read the second double, close the file, and then return it. For read bodies, uh, I basically take in the first int, which is the amount of celestial bodies that we'll have. So this is that. And then we loop through, we skip over the radius, and then we loop through the celestial bodies. So for example, this is 0 to 3. So it'll be 0, 1, 2. It'll count for this for loop. And then we read in all the information, create a new celestial body in the spot that it's supposed to be in this array, and then we return the array at the end after we collected all the information. Okay, so I managed forces arrays by this double for loop right here. So we're looping through all our time, right, with our time interval. And then for the entire, all of the celestial bodies in this bodies array, we calculate the net x force and the net x y, well, net y force and the net x force that all the other celestial bodies will have on it in order to determine how it'll move for each time interval. And so we use this helper method that we went over in celestial bodies to calculate that. And so each celestial body will be in the same kind of index as their x force and y force net. And so we can update it with We can update it with their forces, and then we can draw it for each time interval. So one challenge here was that for this constant, I made it a little too specific. I think it was like 6.687 or something like that. And then my calc force exerted by was like busted, and then everything else here were giving me slightly wrong values. And so I guess these three right here, test calc force exerted by XY, and net force exerted by XY, were the most useful for debugging that. And one key learning point that I learned from this was that helper methods are super useful. Like even here, calc distance, this is a pretty simple formula, but it can look really complicated. And then when you put something like this in another really complicated formula, you can get lost. And then when you have to debug, it's really hard to do so because it just looks like one big long math equation. It's hard to figure out what's going on. And so helper methods are key. Okay, thank you so much.